Hello, welcome back to Mishler Math, and let's talk about, first of all, number classifications. Classifying numbers. We have natural, we have whole numbers, we have integers, we have rational numbers, and we have irrational numbers, and we have real numbers. Okay, those are the categories we're talking about. So a natural number, okay, natural number is 1, 2, 3, and so on. Whole number, 0, 1, 2, 3, and so on. Integers, -3, -2, -1, 0, 1, 2, 3, and so on. Rational number. Okay. Rational number, we have a little bit different situation here. P over Q, where Q does not equal 0, and P and Q are integers. In other words, if it can be expressed as the ratio of two integers. And yes, some of you may have figured out that's where the word rational comes from. It can be expressed as a ratio of two integers. So irrational, by the way, no, that doesn't mean somebody that doesn't act appropriately. Irrational is something that is a non-repeating decimal or a non-ending decimal. Okay, and real numbers, and this is the easy part, real numbers are all of the above. Everything except imaginary number. They're all real numbers. So let's try a couple. Let's classify -2. What is -2? Okay. Well, first of all, is it a natural number? No, it's negative. Is it a whole number? No, it's not 0 or the natural numbers. Is it an integer? Yes, it is. It's an integer. Is it rational? Well, sure, if you put -2 over 1, those are two integers. Can be expressed that way. It's rational. Okay. And, of course, it's real. Try out something else. How about 7? Okay. 7 is a natural number. It is a whole number. It is an integer. It is a rational number. And it is real. Okay. How about -2/3? -2/3. Well, it's not natural. It's not a whole number. Not an integer. But it is rational. And it is real. Okay? And it's rational because if you put divide 2 by 3, 2 divided by 3, you get, okay, 3 times 6 is 18. You get 2, 0, 3 times 6. So you get -0.6 with a line over it, which is a repeating decimal, okay? So if it's a non-repeating decimal, for example, now pi, this is interesting because pi is often said, use 3.14 or 22/7 for pi. Well, you notice a squiggly equal sign. That means that those are approximations because pi is irrational. If you look at any website that shows you pi to a bunch of decimal places, scientists with supercomputers have not been able to find any kind of repeating pattern and any end to pi. So pi is one of those fascinating numbers that never ends. So it's irrational. Another irrational number, square root of 2, is irrational. Okay? But they're both real. Excuse me, please. And so let's talk about the next step here is clear. And next we're going to talk about properties of numbers. Properties of real numbers. Okay? Closure. And let's see. Closure. And I'm going to go with addition and multiplication here. Okay, we're going to break them down into two categories. So closure property says a plus b equals a real number. Okay, and by the way, a, b, and c are real numbers. Now, don't get blown away with this real number business. You're going to find out very soon why we say that these are real numbers, because we're going to talk about imaginary numbers. But for right now, just hang with me. And a times b is a real number. Okay? So that's a closure property. What that means is you can't multiply two numbers together, they're both real numbers, and get a number that's not real. Okay? That's all that means. Commutative property. Okay? Commute. And this is how I remembered this. Commute means to go back and forth. Now, commuter airline would be, for example, the Egypt Air flight between Cairo and Sharm el-Sheikh. That's a commute because you can go back and forth. If you drive to work and back every day, if your parents drive to work and back, they commute back and forth. That's what that means, back and forth. And the commutative property says a plus b equals b plus a. What that means is you can switch these back and forth without having any problem. And a times b equals b times a. Okay? And so something, all you have to do is look at something that's not commutative. Okay? Like, for example, a non-example would be a divided by b, because division is not commutative. Does not equal b divided by a. Okay? You can't do that. And a minus b does not equal b minus a. You can't do that with subtraction or with division. Commutative property only works with addition and multiplication. Remember that. Next one, associative property. And again, the associate. Okay? Numbers can associate with each other in a certain way. So a plus b plus c. Here, the a and b are associating with each other. That is equal to if b and c associate with each other. You see, b is associating with a over here, b is associating with c over here. And the same thing happens here, a times b times c, okay, equals a times b times c, okay. B is associating with C over here, it's associating with A over here. Those two are equal to each other. Okay? The identity property. The identity property says that there is a 0, and it doesn't look like an A, so I better erase that. A plus 0, and by the way, 0 is called the additive identity. Okay? If we add that to the letter A, doesn't matter what A is, we're going to get the same thing. And over here on the multiplication sign, we say that there is a number 1, okay, which we call the multiplicative or multiplicative identity. And if we multiply any number times 1, we get that same number. That's why we call it identity. We get the identical number. Identity, get the identical number. When you add 0 or multiply by 1, you get the exact same number. Okay? And then we got the inverse property. about that. Moved around a little bit. All right. Inverse property. Okay. The inverse property says that A has an opposite. Okay. Negative A. So if you add them together, you get the additive identity. Okay. And every number has an inverse. So A, if you multiply it by 1 over A, you notice this is the inverse of this, because A is A over 1, right? So A over 1 times 1 over A equals 1, which is the multiplicative identity. Okay? So that's how those things work. And then, of course, the granddaddy of them all, and this is the distributive property. This is the one that people forget the most. The distributive property of multiplication over addition. That's the big name. That's the full name. Okay? Distributive property of multiplication over addition just means this. A times B plus C equals AB plus AC. You have heard me talking about this, and you will continue to hear me talking about this. Because where it really gets messed up is where you have negative 3 times 6 plus x, and we forget about the negative sign. Remember, the negative sign goes with that. So that's negative 18 minus 3x would be that. That's what that would be. So make sure you're using the proper properties. And let's try an example if we would like to, and we really would like to do this. Okay, an example would be, let's try A plus B. And write it the right way, please. A plus B times C minus D. How do you do that? Well, first of all, you use a distributive property by multiplying this by both of these. Okay? So A plus B times C. Okay? And I'm gonna do the plus here, even though there's not a plus here, but watch what I'm doing here. A plus B times a negative D. I did that on purpose because I want that negative to stay with the D. I could have put a minus in here, but I want that negative to stay with the D, and I'll show you why. Okay. Now we use a distributive property again on both of these. Okay. And we get AC plus BC minus, because A times negative D is minus AD minus BD. Remember to have the negative sign stick with this. It's a little tricky at times, I understand that, but pretty sure you guys can do this. And we go on to the next one here, which is order of operations. And we've all heard about PEMDAS. Please excuse my dear Aunt Sally. Well, this is a revised PEMDAS because we have to combine a couple things here. First thing we do is parentheses. Okay, anything inside parentheses, starting from the inside out. Parentheses, inside out. So if you have a set of parentheses inside a set of parentheses, you start with the inside. Then we do the exponents, okay? X to the y power. The exponent. You do all orders, okay? Powers. You do those. And then multiplication and division. This is where it gets tricky because some people say you have to do all the multiplication first, then all the division first. That's not true. You do multiplication and division from left to right. And same thing with addition and subtraction. You do it from left to right. Okay? You do it, whatever comes first, addition and subtraction are going to be the same operation. Now, let's talk about, let's do an example. And we've got 18 minus 2 times 5. That's not 2.5, that's 2 times 5 over 15 plus 3 times negative 3. Right away you see a parentheses, so let's get rid of that first. 18 minus 2 times 5 over 15 plus 3 times negative 3 is negative 9, and I can get rid of the plus here. So, and then I've got a multiplication here, okay? So 18 minus 10, 2 times 5 is 10, over 15 minus 9. Some of you might notice that I'm writing everything down, and there's a reason for that. Okay, if you try to skip steps and just don't waste time, just don't write all that stuff down, okay, you're going to get in trouble. 18 minus 10 is 8, 15 minus 9 is 6. Reduce it, always reduce it, 4/3. I'm going to show you another thing here for doing a problem, another way of doing this problem, and you'll get the same answer, but, okay, 18 minus 2 times 5 divided by 15 plus 3 times negative 3. And I'm going to do the inside parentheses first. So I'm going to 18 minus 2 times 5 divided by 15. 3 times negative 3 is minus 9. Now I'm going to do the multiplication in here inside the parentheses. 18. Oops, I didn't want that other one there. 18 minus 10 divided by 15 minus 9 is 6. Okay, and then we have 18 minus 10 is 8 divided by 6, and of course we end up with 4/3 again, like we did up here. Now, important, remember, please do not, do not skip steps or take shortcuts. Now I'm going to give you a couple of problems here to do. And 4 times 4 plus 4 times 4 plus 4 minus 4 times 4. Now I got this off the internet. This is a popular meme. And then I'm going to do, this is even better. This is 48 divided by 2 times 9 plus 3. And we're going to have a little contest here, and this is going to be your last question before I wrap things up. And that's about it for now. I want you to answer each one of these questions, and by now I've already put a question in there and stopped, and so hopefully you did pretty well on that. That's it. Thank you.